Alright, so hello everyone, welcome back. So in this video I'm gonna solve really good problems of integration by substitution. So without much talk, let's get started. As you can see, alright, so where do we start? What is the inside function here? What is your choice for you? Here the inside function, well, you might be thinking about two things. Well, is it 1 over x to the 6, or is it x to the 7, or is it 1 over x to the 7? So many choices. But here's the thing, okay? What is the really inside function? What is the function part that is inside another function by its meaning? Well, 1 over x to the 6 is inside E, right? But 1 over x to the 7 is sort of like outside. So between those choices, I would go stick with 1 over x to the 6, which is literally the meaning of inside function. Behave like the meaning of inside function, okay? All right, now you might see this in different ways. Well, derivative of x to the 7, here's where you're gonna get wrong. You might think, oh, it's not 1 over x to the 7, it's x to the 7, because the derivative of x to the 7 is 7x to the 6. Oh, I have x to the 6 somewhere else in the integral. Okay, so then x to the 7 is u. No, okay, somewhere, yes, x to the 6 is somewhere else in the integral, but we won't be able to cancel it out. Think about it, it is inside E. So being inside another function is way more important when you choose your u. Now you might say that you said in one of the previous videos, you always say that you have to have its derivative somewhere else on the integral. So x to the 7 and its derivative was also somewhere else in the integral. But don't get too panicked, because what is the derivative of 1 over x to the 6? Let's see, okay? So derivative of 1 over x to the 6 is, to take derivatives easily, we can write it as x to the negative 6. We can take it to the numerator, right? Okay, so derivative of this one is negative 6, x to the negative 6 minus 1 is negative 7. So this is negative 6 over x to the 7. So do you see? Derivative of 1 over x to the 6 is 1 over x to the 7. Negative 6 over x to the 7. Do we have 1 over x to the 7 somewhere else? Yes. So this is the better choice, and we can cancel out that x to the 7. You will see, okay? Let's see. So du over dx is negative 6 x to the 7. So this means dx is, if you swap very carefully, this will be x to the 7 du over negative 6. Be very careful, okay? This x to the 6 goes to the numerator and this negative 6 goes to the denominator, right? Okay, now let's replace. So this is e to the u, right? X to the 7, I want to see that cancellation by myself, because I want to make sure that I'm doing it right. X to the 7 du negative 6. Do you see we can cancel out? Now, to learn, as a learning process, here's my proposal for you. Take u to be x to the 7. Just take it, because it's wrong, and try to use it like in normal integration by substitution problem. See whether you can cancel out x to the 6. See it by yourself. See and convince yourself that you cannot cancel out that x to the 6, even though its derivative exists somewhere else in the integral. This is the wrong choice for you. See it for yourself, because when you learn from mistakes, that's gonna stick in your mind for a long time. All right, so where were we? Okay, so we cancel out this. So this is like e to the u over negative 6 integrate with respect to u. Okay, so we can take the negative 1 over 6 outside, e to the u du. So if you integrate e to the u, what you get is e to the u plus c. So the answer is negative 1 over 6. What is u? U is 1 over x to the 6 plus c. So this is it. So you can see the problem is really easy to integrate if you choose your u correctly and carefully. Don't fall into traps. You see, there's a clear trap laid out there. I will show you more problems where the traps being laid in this video session. So natural log y to the 7 plus 1 over y. This is the problem, next problem that I'm going to solve. Okay, so what is the inside function? Here, so it's also tricky one. What is your choice for the inside function? Think about it. Argue with yourself. Okay, so here you can see we have a 1 over y and you have natural log y. See, if I choose my u to be natural log y, okay, can I choose L natural log y to the power 7? Well, it will complicate things. Okay, when you take the derivative, it will still you will be left with 7 natural log y to the 6 in the derivative. Okay, so you don't have this somewhere else in the integral. So natural log y to the 7 is not the choice for you. Okay, you don't have this term outside else, okay, else in this integral. How about natural log u? Its derivative is 1 over y. Can you see 1 over y somewhere else in the integral? Definitely yes, right here. So we can choose natural log y as the u. Now you might ask, well, you already said us that please select this full term. Here we can't do that, right? Here if you're choosing that full term, you have to choose natural log y to the 7 plus 1. It will make things complicated. Again, the derivative of this term will be 7 natural log y to the 6. Oh, times we have 1 over y also. I forgot that in the previous part when I was taking the derivative. This is too complicated, right? You have natural log, not 6 natural log y. Still on the derivative. So that's too complicated. So let's just stick with natural log y. Think about it, y. Okay, these are the things that you should spend your time. So du over dy is 1 over y. So dy here is y times du. Be careful. Now if you replace, this is u to the 7 plus 1 over y. This is y du. Y cancel out. So this is u to the 7 plus 1 du. Alright, so now if you integrate this one, you get u to the 8 over 8. You can integrate u to the 7 separately and 1 separately, which is u plus c. Now u is natural log y, so the solution is natural log y to the 8 over 8 plus natural log y plus c. See, that's really important, right? So think about the other choices for you and think why they are wrong, then that they will lead you to trouble. Okay, all right, so let's do another problem. Okay, here's another interesting tricky one. Cosine pi over x to the 6 over x to the 7. So similar trap like our first problem. Similar trap like our first problem. What is my choice for u? You might again think u is x to the 7, its derivative is x to the 6, it's somewhere else, but the problem is that derivative, it is the inside function. So you don't choose that. What is my u? U have to be literally an inside function, which is this one. So can I take pi of x to the 6? Absolutely yes. Please take that. You can leave behind pi here and just choose 1 over x to the 6 as the inside function, which is also correct. But if you choose pi, which is good to have that constant removed and write it like cosine u, right? Much cleaner. Okay, so let's differentiate du over dx. This will be pi. If you want to differentiate it, I can write this as pi x to the negative 6. Pi is a constant, a number. So negative 6 comes out. So negative 6 pi. This is x to the negative 7. Right? So that means the derivative is negative 6 pi over x to the 7. See? 1 over x to the 7 is somewhere else in the integral. So we are on the correct track. Now dx here is then really, if you switch this, so x to the 7 du over negative 6 pi. Be careful, be very careful when you're making dx subject. Okay, be very careful. Alright, so let's finish it. So this is cosine u, everything is replaced by u, here x to the 7, dx is x to the 7 du, negative 6 pi, x to the 7 cancel out, so cosine u over negative 6 pi. Now we can take that 6 pi out, so negative 1 over 6 pi, be careful, if you integrate cosine you get positive sign, right? Negative 1 over 6 pi sine u here plus c. Now then the solution will be negative 1 over 6 pi sine u is what did we choose for u? Pi over x to the 6 plus c. All right. Okay, so then let's do couple more problems. All right, so oops, okay, what we are going to solve now is natural log x to the 25, see, over x dx. Now think what is u. Think what is u here. What is your inside function? Here my inside function is natural log x. Now think, why can't we choose natural log x times 20 to the 5 as my u? Why can't u be natural log x to the 25? Think why. Okay, I will let you think that why. Now the derivative of du, derivative of natural log x is 1 over x. See, its derivative is somewhere else in the integral. Now you anticipate that we are going to cancel it out, right? So dx is x du. Alright, so this is u to the 25 over x du, x cancel out, so u to the 25 du, if you integrate u to the 25, it's u to the 26 over 26 plus c. Okay, so u is natural log x, so natural log x to the 26 over 26 plus c is the answer. Okay, all right, so those are I think four good problems of integration by substitution. Next video is definitely going to be harder, very hard integration by substitution problems, which you can go by clicking the video that appears in this video, the link that appears in this video right now. Okay, so there we will discuss where the inside functions are not obvious, where the integrals that you cannot directly use the fact that the inside function and its derivative should exist together in the integral, where you don't see that right away. Very hard problem. So I will see you in this video. Okay then, bye bye.